Okay, welcome to the second plenary lecture of our conference, delivered by Hannes Leitgeb. Pleasingly, actually, I shouldn't introduce him to you, but to this audience, but let me characterize him quickly. Hannes Leitgeb is currently chair and head of the Munich Center for Mathematical Philosophy. He received 2 degrees. He studied in Salzburg, one in mathematics, one in philosophy. He was reader at the departments of philosophy and mathematics in Bristol, where he became professor of mathematical logic and philosophy of mathematics. In the fall of 2010, he became chair of logic and philosophy of language and was awarded the Alexander von Humboldt professorship. So currently he is acting there at the Munich Center for Mathematical Philosophy at the Ludwig Maximilians University of Munich. His research interests are well known: logic, epistemology, philosophy of mathematics, philosophy of language, history of philosophy, and especially the application of logical and mathematical methods in philosophy. He's the editor-in-chief of the journal Erkenntnis and has published a lot of articles on all these topics in excellent journals, and he conducted or is conducting research projects on this. Presently, he is working on 2 monographs, one on Carnap's Aufbau. The other one is on a unified theory of qualitative and quantitative belief. So I think this is good enough. We are looking forward to his presentation. Thank you.
Yeah. Thank you very much. Great pleasure to be here in Helsinki and to speak at EPSA. I really believe that EPSA is having a lot of very positive influence on philosophy of science in Europe. And I also assign a high degree of belief to that proposition, which takes me right to the topic of my talk. And that's really the question: how does rational belief relate to rational degrees of belief? So that's the question behind my talk and also behind some of the work that I'm presently doing. As Fritz said, I hope ultimately there will be a monograph that will emerge from that. When I say rational belief, what I mean is you take a proposition, X, and then if you're rational, there are really 3 possibilities for you. You can believe X, that is, believe X to be true. Or you disbelieve X, that is, you believe not X to be true. Or you suspend judgment on the subject matter, on whether X or not X is true. And that's it, right? That's rational all or nothing belief, as it's traditionally understood in epistemology and philosophy of mind and so on. But then, of course, as we all know, there's also degrees of belief. And that's when you take the proposition X again, and you assign to X a number, where this number is supposed to measure your strength of belief in X, or in the truth of X, right? There are different notions of degrees of belief around, but the standard one is the Bayesian one. Degrees of belief are subjective probabilities. And that's the notion of degree of belief that I'm going to presuppose throughout the talk. And then the question is, well, these seem to be 2 kinds of belief, 2 concepts of belief. Maybe there are mental states corresponding to them. So 2 kinds of belief states. How do they relate to each other? And that's the question that I will focus on in my talk. That's interesting, obviously, for epistemology, but for various other areas. Bayesianism is a big thing, as you know. Bayesianism is also a big thing in general philosophy of science. So that's a question that's very interesting for general philosophy of science as well. So obviously, there's Bayesian philosophy of science, so I don't have to argue for that. You might think, well, is the concept of all or nothing belief so important in general philosophy of science? Well, I think it is. Sometimes this is so explicitly, say when belief revision theory is applied in general philosophy of science. But sometimes this is so implicitly. So in traditional general philosophy of science, what's a theory? Well, either it's a deductively closed set of sentences, right? One tradition. Or it's a set of models, or worlds, if you like. That's a semantic tradition. And theories in either sense are those things that are believed to be true by scientists, or which are accepted by scientists in a closely related sense, right? So when you then say theories are deductively closed, what you're effectively saying is what the scientist accepts or believes in, that's deductively closed, right? If you think our theories is given as a set of models or worlds, then that's very close to a possible world semantics for what the scientists believe. That is a possible world semantics of belief, right? So really the question that I'm interested in could also be put to some extent, how does traditional general philosophy of science, sort of in the logical tradition, relate to the more recent Bayesian endeavors in general philosophy of science? There are, of course, lots of answers to my question, right? The most radical one is Richard Jeffreys. That's radical Bayesianism. He would just propose, well, throw away the notion of all or nothing belief altogether, right? That's sort of epistemological Stone Age, right? But now we're in the phase of enlightenment, and that means we are using our subjective probabilities, and that's it, okay? Now, that's not what I would recommend. In any case, if you want to follow Richard Jeffreys' advice, you have to be prepared to throw away a lot of work, right? I mean, thousands of years of work, if you like, okay? So you need really strong arguments, right, if you want to make that happen. And secondly, I'm from Austria. We're neutral, right? So I can't do that. That is why, instead, I'm going to propose a joint theory of belief and degrees of belief. So I'm not throwing away either of the concepts, that's fine. But what I'm doing is I want to give you a way of relating the two, such that, roughly speaking, this is super additive, right? The sum of the two parts will be more than the two parts in isolation, okay? I will give you what I call a bridge principle for the two concepts of belief, a principle in which both belief and degrees of belief, both concepts figure. And this bridge principle will tell us how the two relate to each other, and then we'll draw consequences, conclusions from that bridge principle. And that bridge principle I'm going to explain at the beginning of my talk. That's what I call the Humean thesis on belief. And I'll give you three consequences of it. One is doxastic logic, the logic of belief will follow from it. The second is we'll derive something from it that's called the Lockean thesis in this whole literature on acceptance. So you can see a lot of British empiricism today, right? And the third consequence is we will be able to show that a very simple qualitative decision theory is also probabilistically reliable in a sense. It's reliable from the viewpoint of Bayesian decision theory, if the bridge principle holds. And then I'll give you two concrete example applications, and we'll draw some general conclusions on belief from that. In all of that, I will presuppose that we're dealing with sort of perfectly rational agents as far as their reasoning goes, I mean. Okay? So if we were to ascribe beliefs in the way that beliefs take, say, sentences as their contents, in my case it will be propositions, but let me make the point with sentences. If sentences were the contents of belief, then my agents would be such that they believe every logical truth, independently of how complicated it is. They would believe them to be true. Right? So my agents are logically omniscient. And similarly, as far as subjective probabilities are concerned, my agents will assign probability 1 to all the logical truths, independently of how complicated they are. Right? So this is sort of a typical assumption that people are making. To some extent, it's simplifying the situation. And to some extent, it shows that this is really a very normative business here. Okay? In any case, I'm going to make that assumption throughout the talk. Okay? I don't have a lot of time to discuss literature. I mean, there's a lot of classic literature on the topic of acceptance and subjective probability, as you know, right? I mean, I mentioned already Richard Jeffrey, but Henry Keiberg, Isaac Levi, before them Carnap and Hempel and all of that. There is also really interesting recent literature. Let me just mention Hunty Lin's and Kevin Kelly's work recent work on acceptance and probability. They have their own theory, which is slightly different from mine, but there are interesting relationships. If you're interested in that, please just let me know later in the questions and answers session. Okay? All right. So let me first tell you about my bridge principle, the Humean thesis on belief. Okay. So let's do now proper philosophy. Okay? Not this philosophy of science that you're all doing, right? So that means we have to be very historical now, and everything has to be serious and so on. An opinion or belief is nothing but an idea that is different from a fiction, not in the nature or the order of its parts, but in the manner of its being conceived. An idea assented to, so that's belief, right, feels different from a fictitious idea that the fancy alone presents to us. And this different feeling I endeavor to explain by calling it a superior force or vivacity. So that's Hume in the Treatise of Human Nature. And so far, what he's saying is basically what people usually are taught when they hear about Hume on belief. So for Hume, a belief is a lively idea, a vivacious idea. Okay? That's the superior force or vivacity. But then again, he continues in that quote in this way, or solidity, or firmness, or steadiness. And you can see that these are terms now that belong to a different category. They are not so much to do with sort of how strong something is, but how stable something is. And what he seems to say, other than strength, a belief needs stability, right? Resiliency, if you like, or robustness. Its true and proper name is belief, which is a term that everyone sufficiently understands in common life. It gives the ideas of the judgment more force and influence, makes them appear of greater importance. So this is this vivacity conception again. But then also, belief infixes them in the mind, that's the stability component again, and renders them the governing principles of all of our actions. So belief is based, in some sense, on action. And then again here in the treatise in the appendix, the mind has a firmer hold or more steady conception of what it takes to be a matter of fact, that is, of what is believed, than of fictions. And this idea that in Hume on belief you actually find something like a stability theory of belief, that was taken up by a historian of philosophy, Louis Leitgeb. He works at the University of Michigan. And he wrote a really interesting book on that. It's a historical book. But it's also, to some extent, an epistemological book. It's called Stability and Justification in Hume's Treatise. And what he argues for there is, traditionally, Hume interpretation has it that beliefs are lively ideas. In my interpretation, according to Hume, beliefs are steady dispositions. That's the stability thing, right? So he doesn't say, vivacity is unimportant for Hume, not at all. But it's very important to look at dispositions to vivacity. That's what he emphasizes. As he says here, a disposition to vivacity is a disposition to experience vivacious ideas, ideas that possess the degree of vivacity required for occurrent belief. So when Hume is emphasizing vivacity, he's talking about occurrent beliefs, right? And he's not always clearly distinguishing between occurrent beliefs and dispositional beliefs. What is even more important than these occurrent beliefs themselves is the disposition to produce them. Some dispositions to vivacity are unstable in that they have a tendency to change abruptly. Such dispositions in Hume's terminology lack fixity or stability. Hume, in effect, stipulates that a dispositional belief is an infixed disposition to vivacity, or a stable disposition to produce vivacious ideas. Okay? So once such a disposition is triggered, then you find a lively idea, but you also need to look at the disposition, and that disposition has to be stable, according to Hume on belief. That's the idea. And then in the book, Leitgeb tries to show that there is a twofold role that stability plays in Hume on belief. On the one hand, it belongs to the nature of belief to be stable, but then secondly, a belief, something that's stable, has some kind of defeasible or prima facie justification that comes with it, just because it's stable. It's defeasible, but it has that justification as well. So it's not just interesting from the point of view of philosophy of mind, but also from the point of view of epistemology. And that's the idea that I'm going to take up. So in a nutshell, the conception that I want to develop is beliefs are stable dispositions to have ideas with such high degrees of vivacity, using that Humean term. And then on the basis of these stable dispositions, we do the usual thing, reasoning, acting, asserting, and all of that. That's the idea. Now, of course, as you can imagine, I'm not really interested so much in what Hume thinks about belief, right? Ultimately, I'm interested in belief, okay? So fortunately, independently of Loeb on Hume, right, this seems to be a natural idea to have anyway, okay? So think of the different roles that beliefs play in our mental lives. Like, think of reasoning, right? Say I have certain beliefs, and now I perform an act of suppositional reasoning, right? I say to myself, suppose A is the case. It would be really bad if just by the act of that supposition, I got rid of most of my beliefs, right? Because if I did so, then I couldn't make use of these beliefs in this context of suppositional reasoning anymore. So there must be something about beliefs that makes them stable or resilient with respect to suppositions, right? Or think of action, right? I believe that there is a beer in the fridge, right? I desire to have the beer. So belief-desire model, I commit myself to action. I walk downstairs towards the fridge, right? If just by getting new but not unexpected evidence, right? Stuff that is lying around in my house and so on. If just by having that evidence, it was easy for me to get rid of my belief that the beer is in the fridge, right? I would never be able to finish my action, right? Or at least I would never be able to finish my action justifiably. Okay? So it seems that beliefs must be stable under acquiring new evidence, okay? At least in some sense. Same for assertability or asserting, right? There's obviously a close relationship between beliefs and assertions. That robustness or stability plays an important role for assertability, that had been observed already by Frank Jackson in the late 70s in his work on conditionals. And then this was taken up by David Lewis again. So for example, say I consider a disjunction, A or B, okay? And I give it a high probability. Maybe because I assign already a high probability to A, to one of the disjuncts, right? Then according to the standard Gricean story, right, well, you shouldn't really assert A or B. You should assert A, right? That's more specific. Okay? But then Jackson argues, well, there could actually be a point in asserting A or B. And the idea might be, I assert A or B, maybe because I think A is so likely, right? But then again, A or B could be such that even if I or someone else got the additional information not A, right? A or B would still be high given that new information. That could be, right? And it could also be that if I acquire not B, then again A will still have a high probability. So the disjunction could be robust with respect to ruling out either of the disjuncts. And just that in itself could make A or B assertable, right? And if I really assert A or B, then it might be important for this thing to have that property, right? Because I assert A or B, you don't know maybe why I do that. And then you run with that information, right? You don't know that I did that because A was likely, as far as I can see, okay? You might have A or B, right, in your mind, as it were. And in the future, you might actually acquire the evidence not A. And then maybe you would draw the conclusion A or B, not A, therefore B. And so you would end up with B, okay? So it better be the case if I say A or B, that I also think, well, this would even be likely if someone acquires the new evidence not A. Okay, so that's roughly what Jackson argues for here. And what Lewis adds to this is the idea, this is even so if roughly I assert things to my future self. Okay, meaning if I believe something. If I have an A or B, and by memory, okay, I retain that so that my future self can make use of that information. That's like asserting something to my future self. And the same should hold there. So there should be some stability if I have a belief in a disjunction, for example. Okay? And that's why Jackson thinks robustness is an important ingredient in assertability. All right, I'm now going to make that precise. And you can already roughly see how that is going to go. In my examples now, I used stability with respect to supposition, acquiring new evidence, right, updating. So ultimately, what I mean by stability will be stability under conditionalization. Okay. All right, but we're not quite there. First, for this Humean story, what about our degrees of vivacity? Well, long story cut short, I'm going to identify degrees of vivacity with degrees of belief, subjective probabilities. Okay. There is actually work done that tells us this might be a good idea anyway. There's a very nice paper by Patrick Marr where he more or less argues for that. Okay, more or less, I'm cheating a little bit, but just a little bit. Okay. You might think, well, sure, Patrick Marr has done a lot of work in Bayesian confirmation theory. Sure, he thinks that, right? But that's a different kind of paper. It's a paper from the early 80s, and it's a paper in the Hume studies, right? So it must be true, right? I mean, you can't argue with the Hume studies, right? So I'm going to presuppose that. So this is then the Humean thesis on rational belief. It's rational to believe a proposition, just in case it's rational to have a stably high degree of belief in it. So I've now replaced degree of vivacity with degree of belief, and that's what you end up with, okay? So this is this idea of belief is an fixed disposition to vivacity, okay? Rational belief corresponds to stably high rational degrees of belief, stably high subjective probabilities. The only thing that we need to clarify now is the stability. What does it mean to have a stably high degree of belief in a proposition? And there, as I already predicted, I'm going to plug in stability under conditionalization. And again, there is work done that makes it seem plausible that this is a good idea. Okay? And what I mean here is Brian Skirms's work on resiliency, okay? Which he worked on in the late 70s and early 80s in a couple of papers and in a book. In his case, this notion of resiliency that he introduced was supposed to play a role in his theory of objective probabilities and causality. Okay? That's not so in my case. I will use something like his notion of resiliency, but plug it into my theory of belief. Okay? But formally speaking, it's the same idea, really. And resiliency in Brian Skirms's work is really resiliency, stability under conditionalization. And I'm going to do that in a formal framework that is just as usual, standard thing. We presuppose some set of possible worlds, call it capital W. I'm going to assume that the set is finite. There is also sort of a version of that theory for the infinite case, but I'm going to restrict myself to the finite case. Propositions, by that I just mean subsets of the set of possible worlds. And when I deal with probability measures, that's always a degree of belief function of a person at a time. And that degree of belief function is a subjective probability measure, satisfies the axioms of probability. And it assigns degrees of belief numbers to propositions, to subsets of our set of possible worlds. So just the usual framework that you would expect. And then, as a first approximation, my Humean thesis on belief looks like this. So we fix the agent, right, at a point of time, call BEL, Bell, the class of believed propositions by that person at the time. Okay, so a proposition is believed if it's a member of that class. Okay, so if X is a member of Bell, then it's believed. Usually I'm going to write this like this. X is believed, okay, but formally it means X is a member of Bell. P will be the same agent's degree of belief function at the same point of time. And then my question was, at the beginning of my talk, how do Bell and P relate to each other, right? And the answer is this. I'm going to postulate that for all propositions X, X is believed if and only if X has a high probability, greater than some threshold R, under all conditionalizations on propositions Y that have positive probability. Otherwise, the conditional probabilities are not well defined. And where Y is from a certain class of propositions that are sort of salient in that context. Okay? So what I say here is a proposition X is believed if and only if the probability of X is high enough, given whatever Y's that have positive probability, if they come from this certain set, this here. Conditionalizing on any Y in there will lead to a probability for X, the belief proposition, that is high enough. Okay? So it's stable under conditionalization with respect to all the Y's that are in this class. Okay. In particular, if that class includes capital W, the set of all worlds, which has probability 1, of course, right? Then this will reduce to the absolute probability of X, right? The conditional probability of X given the tautological proposition. That's the absolute probability of X. So if a proposition is believed, then its degree of belief will be above a threshold. But additionally, if y is big and includes lots of other members, then the idea is that this high degree of belief for x will be retained by conditionalizing on other y's in that set. That's why it's stability. Okay, so the remaining question here is, what's this strange class y here, right? What are the y's, propositions y, that we should plug in here? And that's not so clear. But there is hope, right? That's why this is green. Okay. So basically the next job to carry out is we have to find the right class here, okay? And then we're done. And now I'm going to run through a couple of options that we have. Okay, this is not an exhaustive list, but it's a quite natural list. Okay. In any case, the bigger this class y, the stronger the constraint on Bell, right? If this is a big class, then we're going to demand of the believed propositions x that their probabilities will stay high under conditionalization on lots and lots and lots of propositions, right? So that's a big constraint. Whereas if this set here, this class here of propositions is small, then the constraint is not that demanding, right? We just say, yeah, it has to be high, given conditionalizations on a couple of propositions, okay? So the larger the y here, the more cautious the agent's beliefs will be, right? And the smaller this class here, the braver the agent is with respect to her beliefs, okay? The question is now just how large or how small should that class y here be? So here's an option, make it very small. Let that class just consist of capital W and that's it. Okay. Now obviously in the way that I've set up my talk, this doesn't seem very stable, right? So basically this means we demand that a proposition is believed if and only if its probability is high enough. That's all we're saying here. Okay. So if the only y that we look at here is capital W, then this reduces to, well, the probability of x has to be high enough. And that's what's called the Lockean thesis in the literature. X is believed if and only if the probability of x is high enough, greater than some threshold. Okay. So my Humean threshold, right? That's what I used here, right? This R here, which could be some number. Okay. I'm always assuming it's greater or equal to 1/2, but otherwise it's sort of contextually given, you might think. Okay. That this Humean threshold then becomes a Lockean threshold in the Lockean thesis. Okay. Now, as I said before, this just by itself doesn't guarantee enough stability, right? We're just saying x is believed if and only if x has a high probability, right? Where's the stability gone, right? This might actually be right in some contexts, who knows? But as a general account of belief, there's not enough stability. Okay, we would have to add further requirements. Okay, that's not good enough. Let me relax that a bit. Instead of saying, well, which y's am I looking at here? The necessary ones, right, capital W. Now I'm saying the certain ones. Let's demand stability under conditionalization on propositions that the agent is certain about, right, to which the agent assigns probability 1. Well, as you can see easily, that reduces to the same thing that we just had, right? That reduces again to the probability of x is above a threshold, is above R. So this doesn't help, okay? Not enough stability. Okay. So let's get less demanding, okay? More y's here. Let's say we demand for x to be believed that the probability of x is high enough, whatever y we presuppose, that is itself believed. Okay? So now we have Bell on both sides of this if and only if, which might worry you. I will return to that. But for the moment, just follow my lead, please, okay? So this would be a kind of coherence theory of belief, right? X is believed if and only if whatever y that is believed, I presuppose, if I conditionalize on it, x will still have a high probability, okay? Sort of different beliefs that the agent has, right, do not destabilize each other in terms of probabilities. That's what I'm saying here, which sounds like a coherence theory of belief. Okay? So here's an example. Here are 3 propositions, A, B, C. They have all a reasonable probability above 1/2, and even if I presuppose, I conditionalize on either of them, the other 2 will still have a high enough probability, greater than 1/2, say. So that's an option, and I think we should explore that option. That's interesting. So you can see it's really kind of a family of stability conceptions of belief that one can develop in this way, right? And that's one of them. The only thing is, I did investigate that option a little bit and think of Carnap on explication, and explication should be fruitful, right? You should be able to derive lots of interesting general stuff from your explication, right? And I just didn't manage to derive interesting general stuff from that, okay? So as far as I can see, that's an interesting option to look at, but not a fruitful one, okay? But maybe you prove me wrong. That, in a sense, would be great, right? Then there's more stability conceptions of belief around than I would have thought. Okay. So that's not, I just don't see that's a fruitful option. But in principle, it would be an option. Okay, let's get even less demanding, a big class of y's here. Let's take all the y's that have positive probability, right? Which are sort of probabilistically possible from the viewpoint of the agent. And we demand for x to be believed that x has a probability that's high enough given all of them. That's really, really, really cautious, because that reduces to x is believed if and only if the probability of x is 1, right? X is certain about that. And again, in certain contexts, who knows, that might be the right option. Some people are defending that view anyway, right? But as a general account, now we seem to have too much stability, right? If something has probability 1, then by conditionalization, you can't get rid of that anymore, right? That's a lot of stability. That's maybe too much stability, okay? And it doesn't seem to get the data right, in general at least, right? So I honestly believe that on Saturday in the evening, I'll be back in Munich. I honestly believe that. But the usual thing, if you offer me a bet on that proposition, right, where I get €1 if this is so, and I lose €1 million if this is not so, I wouldn't accept the bet. And I don't feel irrational, okay? So it seems maybe I have a high probability that I give to the proposition I'll be back in Munich on Saturday in the evening. But I won't give it probability 1, just a high probability, okay? But I honestly still believe that proposition in this qualitative all or nothing sense. So this can't be right, at least not as a general account. Okay. So what we found is we've tried out different conditions, right? Here we got really cautious, right? Here we probably got too brave, not enough stability. So it seems we would need to find something that's in between. And that's what I'm going to propose now, okay? And the answer is, okay, no, that's at least another suggestion to look at. Take all the y's here that are possible from the agent's point of view, that the agent regards as possible. And what do I mean by possible? I mean the negation of these propositions, those negations are not believed. I mean the dual of belief, right? So like when you have necessity, you get possibility out of that. And so you get from belief to possibility. And I want you to use that notion of possibility and plug it into our explication of the Humean thesis here, okay? So the idea is for x to be believed, the probability of x has to be high enough, given any y that the agent regards as possible. That is, where the negation of such a y is not believed by the agent. Okay? Sort of it's a serious possibility, such a y, right? It's not been ruled out as yet from the viewpoint of the agent, in the qualitative sense. Okay? And that's what I'm going to suggest. Okay? So this is my official explication of the Humean thesis. Given subjective probability theory in the background, I'm always presupposing that. That's the main postulate of my theory. Okay? Now I have actually alternative versions of that theory, different, as it were, axiomatizations. And I can prove all of them equivalent. But I've picked one here, and that's this one, the Humean thesis. Okay? All right. Now, let me add a couple of comments, general comments, before we have a look on what this entails, what this gives us. First of all, what is sort of nice about that explication is we needed here this clause that the degree of belief of y is greater than 0 anyway, right? For conditional probabilities to be the standard conditional probabilities. I mean, there would be ways of generalizing this. I won't go into that here. So this means we're looking at y's here that are sort of probabilistically possible. And now we add that these y's also have to be possible from the viewpoint of qualitative belief, right? So they need to be possibilities in both senses, in terms of all or nothing belief and in terms of subjective probability. That's nice. So they make a nice match here. Secondly, when you see this for the first time, you might think to yourself, well, this looks still very strong. That is, it still looks very demanding on Bell, right? So take any absurd y, you might think, right? Why would a belief proposition still have to have a high probability given that y, okay? But the point is, the y's can't be too absurd. Okay? So for example, it's not good enough to have a y that's a logical possibility, right? It needs to be a doxastic possibility. Okay? Think for a moment back to the Lockean thesis, which said something is believed if and only if it has a high enough probability. That's not exactly what we have, but that might help intuitions going, okay? If you believed in the Lockean thesis, then it would follow that you regard a proposition as possible if and only if its probability is sort of non-negligible. For example, say you demand x is believed if and only if the probability of x is greater than 0.9, then you end up with x is regarded as possible by the agent if and only if the probability of x is greater than 0.1. So it means propositions are possible in that sense if they have some probability that is at least above some very minor threshold. Okay? So no Cartesian demon proposition, for example, would have this probability greater than 0.1. Okay? So that means you can't really plug in any y's that you like here, right? There is a constraint on the y's. So overall, this might not be as much of a constraint on Bell as you might think. Okay, that's what I'm saying. It's still a strong constraint. And what that means we're going to see later to some extent. What I'm now going to do is take that idea, the stability idea, fleshed out in this precise way, and then I draw some conclusions from that. Okay? And in this way, I'm going to show that the explication is fruitful. You can derive interesting, non-trivial general statements from it. Okay. One final remark. So back to this thing. In a sense, we have Bell here in our explication on the left-hand side. But in some sense, we also have it on the right-hand side, right? Because pos y really means the negation of y is not believed. Okay, so Bell you have on both sides of this if and only if. So isn't that some kind of circularity, right? And the answer is sure, but it's not a vicious circularity, okay? Because this is not supposed to be a definition of Bell in terms of something else, maybe of Bell in terms of P. That's not the idea that I have behind my theory, okay? In other words, it's not supposed to be a reduction of Bell, of all or nothing belief, to P, to degrees of belief, okay? If it was a definition, then this wouldn't be good, of course, but it's not. You should think of that postulate as a joint constraint on both Bell, belief, and P, degrees of belief. So in order for an agent to be rational, her beliefs and her degrees of belief have to be such jointly that they satisfy the Humean thesis. That's the idea. And then, at least as far as I can see, there is no problem, right? That it's of an if and only if form where Bell figures on both sides. That's not the issue. Both Bell and P have to be such that this thesis holds. And that's what I'm going to assume for the rest of the talk. Okay, so don't think of it as a reductive program where we want to some extent at least, get rid of Bell in favor of P. All right, so here's the first consequence that this explication has. Doxastic logic, the standard logic of belief, and I'm really happy to say that in Helsinki, right, in the Hintika sense, right, follows from it, okay? So if P is a probability measure, Bell and P together satisfy the Humean thesis with some threshold R, that's the Humean threshold that we had, and the contradictory proposition, the empty one, is not believed, then all the principles of doxastic logic follow, right? In particular, it follows that if X is believed and Y is believed by our perfectly rational agent, then also their conjunction or intersection X and Y is believed. Okay? And that's the point where you should think cool or something like that. It doesn't have to be cool. I mean, something positive. Okay? Because, just in case you didn't realize, I wanted to remind you. Okay? Because, for two reasons really. First of all, either, typically in the literature, you presuppose something like that if you come from the logic camp, as it were. Okay? Then you like that. Or, if you come from the probability camp, you deny it usually. Okay? In any case, you don't really properly argue for it. Okay? But here, we've actually derived the laws of doxastic logic from a sort of slightly deeper foundation, namely from probability theory plus the Humean thesis. And that's interesting, I think. And secondly, what's nice about that, it's still very much in a probabilistic context, right? It's to do with high, okay, stably high probability, but it's still to do also with high probability, right? So maybe you wouldn't expect that belief is closed under conjunction, right? Because of the typical lottery problems. But here you just get that as a corollary to our Humean thesis. Okay? So that's nice, I think. This also means for such an agent with a finite set of possible worlds in the background, right, you can take the conjunction, the intersection of all the belief propositions, right? And they will still be believed. But this must come to an end, right? There must be at least the smallest proposition that is believed by the agent. And a proposition is then believed if and only if it's implied, a superset of that smallest belief proposition. That just follows from what I have on the slide here, right? I call that least belief proposition B sub W. And it always exists in a context like this where the Humean thesis is presupposed. Okay? So this means what we get from the Humean thesis is a standard possible worlds picture of belief that just drops out of it. Okay? So you have B sub W here, the least belief proposition. Sometimes this would be called the set of doxastically accessible worlds, right? And then a proposition X, like this big one here, is believed if and only if it's a superset of B sub W. It's true in all the worlds in B sub W, right? And a Y here, for example, is possible if and only if it has non-empty intersection with B sub W. It's true in at least some of the doxastically accessible worlds. Okay? So it's just a standard picture of possible world semantics for doxastic logic that you get out of that. So that's nice. Here's a concrete example. So that's a probability measure here. There's really 8 possible worlds. One has probability 0. Okay, so we can sort of suppress that. It's been ruled out probabilistically already. And the numbers for the remaining 7 worlds sum up to 1. It's a probability measure. And then if you now keep that probability measure P fixed for the moment, okay, then the question that you now might ask yourself is, with P being fixed, which kind of bells are there so that bell together with the P satisfy the Humean thesis? Right? So that's a natural question to ask. So given that P, what bells, what classes of belief propositions are there that together with P would satisfy the Humean thesis? And the answer is there are 7 such bells. And instead of giving you the full classes of belief propositions, it suffices to give you the logically strongest, the least belief proposition, right? Because it generates all the propositions that are believed. So there are 7 options here for a B sub W such that B sub W, or bell if you like, together with P satisfy the Humean thesis. It's these sets here. This set has probability 1. So if this is B sub W, then the agent believes something if and only if it has probability 1. But that's just one option out of 6, right? The other 5 options are such that the agent ends up believing something that has probability less than 1. So we don't always collapse into this proposal of X is believed if and only if probability of X is 1, which is good, of course. The smallest option here would be this one, right? So that's the bravest option. The bravest agent satisfying the Humean thesis here would believe all the propositions and only those that are supersets of W1. Okay? And if he does so, he satisfies the Humean thesis. And this also means, by the previous theorem, he will obey the laws of doxastic logic. Okay? You can see that these options there are to satisfy the Humean thesis, these B sub W's, they are nested like Russian dolls, right? They get bigger and bigger. Or they look like a sphere system, right? As you have it in David Lewis's semantics for counterfactuals, or in the semantics for belief revision theory, or in some theories of verisimilitude, or and so on. Okay? So it's sort of, you get a really, really nice formal structure. Okay? And if you like formal stuff in philosophy at all, right? Of course, at this point, you will think to yourself, wow, there must be something right about this, right? Because it looks so nice, and so on. Okay? Well, if you don't think so, I think so. I'm sorry. So this looks good. Okay? This also means that what we get from the Humean thesis, formally speaking, is a preference order on worlds. So W1 is the most preferred world. And then there comes W2. It has rank 2, as it were. And then, as you can see, the next bigger option to satisfy the Humean thesis is one where you throw in W3 and W4. So there's a tie between the two of them. They both have rank 3. Okay? Although their probabilities are different, right? Doesn't mean that their probabilities are the same. And so on. So you get a ranking of worlds effectively when you demand the Humean thesis to be satisfied. I'll return to that. Okay, here's a little diagram that pictures all the probability measures there are on 3 possible worlds. Okay, so each point in the triangle represents a probability measure. This one here assigns probability 1 to this world and 0 to the others. This point here assigns the same probability 1/3 to each world, or their singletons, right? If you move closer here, you get a higher probability again for W1 and so on. Okay, each point in the triangle is a probability measure on 3 worlds. And then you can determine how the possible ways of satisfying the Humean thesis, given the probability measure that you have at a certain point. For example, here, right? I pick a probability measure here in that little triangle. That's my degree of belief function, say. Then, that's what I have here with these numbers. You get the following. If you want to satisfy the Humean thesis, believing W1 and all its supersets, that's an option. Or believing W1 and W2, taking that set as your set B for W, okay? That's an option. Or taking all 3 worlds together, that's an option. So with your probability measure being in that triangle, there's 3 ways of satisfying the Humean thesis. Right? One is you believe basically just capital W, the set of all worlds. That's the option again, where you believe only things that have probability 1. But then there is 2 options here, B sub W being W1 or B sub W being W1, W2, where you end up believing something that has probability less than 1. And you might actually wonder now, where are the probability measures where the only option, the only way of satisfying the Humean thesis is only to believe stuff that has probability 1? Where are the probability measures where the Humean thesis collapses in X is believed if and only if X is probability 1? That's a good question to ask. And the answer is, the only probability measures where this is the case, okay, where I can only believe stuff that has probability 1. These are the probability measures on these line segments here, these 3 line segments, and the vertices of the triangle. In other words, almost everywhere in the triangle, you're dealing with a probability measure so that you can satisfy the Humean thesis without necessarily giving probability 1 to all your belief propositions. Okay? So sort of if you close your eyes and you pick a random probability measure from the triangle, then you're sort of guaranteed, in a sense, right, to end up with 1 where you can believe propositions that have probability less than 1. So that's good to have. So that's why I'm saying it's not too demanding, this Humean thesis. Okay? And actually you can do more. I won't do that here, but if you extended your notion of belief from absolute belief, believing proposition X, to a notion of conditional belief, believing X on the supposition of Y, that would be the qualitative counterpart of conditional probabilities, right? So for some of you, this might seem like an unusual move. Okay, what's that? Okay, but actually, what you get in this way is a version of belief revision theory. So this conditional belief operator would correspond to the belief revision operator in belief revision theory, or it would correspond to non-monotonic inference relations in non-monotonic reasoning. So this has been explored in the literature. Okay? And if you did the same thing, everything that I did so far, again in terms of conditional belief, the binary belief notion rather than the unary one, you get the corresponding results. You can derive from probability theory and the Humean thesis the axioms of belief revision, the axioms of HEM belief revision, okay? From the standard theory of belief revision. So the whole thing extends, that's what I'm saying, which is nice. Okay? All right, second conclusion. Remember, that was the Lockean thesis. X is believed if and only if the probability of X is high enough with a threshold, contextually determined in some way, call it S. So that's the Lockean threshold, right? In the Humean thesis, we had the threshold R, that was the Humean threshold, but that's the Lockean threshold here. Now, what I can derive on the basis of probability theory and the Humean thesis again is this. Actually, if the Humean thesis holds, then there is always an instance of the Lockean thesis that will hold as well. So you can derive that, given the Humean thesis, there is a number that you can plug in here so that X is believed if and only if the probability of X is greater than or equal that number. The Humean thesis entails one instance of the Lockean thesis. Now, what's the Lockean threshold that you have to choose here? It's the probability of the logically strongest or least believed proposition. Okay? So what that number is will depend both on Bell and on P. If you take the probability of the least belief proposition, that's a number, right, above 1/2, and if you plug it in here, then you get the Lockean thesis to be satisfied with this Lockean threshold. Okay? So that's nice because there is strong, right, intuitions and strong arguments in favor of saying, well, I believe something rationally if and only if I assign to that proposition a high enough rational degree of belief. So it does sound very plausible. And actually what you find here, that is also true. If the Humean thesis is true, then that is also true. Okay? Now you might think, I don't quite understand. Didn't we rule out the Lockean thesis before because it doesn't give us enough stability, right? That was a thought that we had. That's right, if you're free to choose any threshold you like for the Lockean thesis. But what I'm saying here is, if you have the stability assumption on belief, then there will always be a Lockean threshold here such that Lockean belief coincides actually with Humean belief. If you pick your threshold rightly, then you'll end up with stable beliefs. You might not have seen that from the start, but that's the way it is. But it means you can't choose the threshold here arbitrarily. You can't just say, now I want my Lockean thesis to be satisfied with threshold 3/4. That's not how it's supposed to work. Okay? It has to be a specific number here that is given by the probability of the logically strongest belief proposition. But at least you get some instance of the Lockean thesis going. So in my example from before, remember that was our probability measure, P fixed. These were our options for Bell or B sub W. The corresponding thresholds for the Lockean thesis, for the instance of the Lockean thesis that we could derive from the Humean thesis, are these numbers here. So if that's the option that you pick, Humean thesis will be satisfied, and the threshold will be 0.54. If you pick that to be your logically strongest belief proposition, then the Humean thesis will be satisfied again, and your Lockean threshold will be 0.882, and so on, up to 1. Okay? Now you can see there is quite a gap between 0.54 and 0.882. So you might think, why don't I choose a number in between? And you might have bad luck. You might end up choosing a number, right? So that if you get your bells from the Lockean thesis for that number, the belief propositions won't be stable anymore. Okay? So you can't choose any old number in the Lockean thesis, but at least some instance of the Lockean thesis follows always from the Humean thesis. Now, what does this mean for the lottery paradox, right? So say we're given a probability measure that is uniform, right? We have 1 million tickets, same probabilities for each of them, and you assume the Humean thesis. Then what's going to happen? The answer is, that's like when you picked the probability measure in my triangle before, that was on these line segments, right? Like in the center of the triangle. And as I told you before, there are some probability measures where the Humean thesis can only be satisfied by believing capital W as a logically strongest belief proposition. Or in other words, in this case here, if this is my probability measure P, then you can only satisfy the Humean thesis by believing that some ticket will be drawn and not believing anything that's more specific than that. Okay? So the theory predicts you can believe that some ticket will be drawn, of course, but you can't believe of any ticket that it won't be drawn. Okay? Now this is not, some super surprising fancy result, right? It's a bit boring, actually, but that's what, some epistemologists would predict if this was about knowledge rather than belief, and that's what you get here too. Okay? And the corresponding Lockean threshold will be 1 here, right? So it's sort of kind of a trivial thing, but in any case, the theory doesn't fall prey to the lottery paradox. Now, say we change the setting a little bit, okay? Say we're in the lottery situation again. 1 million tickets, fair lottery, we know about that. But the only thing that we're interested in is whether ticket I will be drawn or not, whether ticket I will win or not. Okay? That's the only concern that I have, okay? Ticket I could be Fritz. Fritz could have that ticket, and of course I don't want him to win, say, right? So I only care.
Good idea.
Yeah. So if that is the setting, right, then the underlying partitioning should maybe look like this. You really have 2 possible worlds. One in which the ticket that Fritz has wins, and then you have one big fat world, right, which comprises all of the other worlds, right, where some ticket wins that is not his. Okay, and you collapse them to one world. So the underlying space, right, The underlying algebra of propositions is much more coarse-grained now. But you still get probabilities for that. This will still have 1 over a million, and this will have the rest of the probability, right? In that setting, you assume the Humean thesis again. The theory gives you two options. Either you're cautious as before, so you only believe that some ticket will be drawn and nothing more specific. Or, second option that you now have, you believe that this is the actual world. That is, his ticket won't win. And that's an option. Okay? That is open according to the normative theory that I'm suggesting here. Okay? And this would be the corresponding Lockean threshold. So the idea is now that you might think there is a clash of intuitions in the lottery paradox, right? From the viewpoint of a very coarse-grained space, it's sort of okay to believe of ticket I that it won't win. That's when you have a context where this is the partition. But then again, in the other context, where you have sort of the fair partition, right? Then the only thing that you should believe is, well, some ticket will win and I can't tell you anything more. Okay? And if you forget about the contextual differences between the two, you might have sort of the clash of intuitions that is exemplified by the lottery paradox. But if you tear it apart into two contexts, you're fine. And that's what happens in the theory. Okay? So in a sense, the theory can handle the lottery paradox. But there's a price. The price for the theory that I'm suggesting, the price for the Humean thesis, is a very strong context sensitivity of rational belief. It's sensitive, like in the Lockean thesis, to a threshold. But the space of admissible thresholds that you can plug in the Lockean thesis, that's also depending on what your probability measure is like and the partition is like and so on. Okay? So the first thing that you should ask yourself when you ask sort of what's the rational beliefs of an agent is what's the underlying partitioning of worlds that the agent presupposes? What's sort of, for the task of reasoning that is in play here, what's supposed to be indistinguishable and what's supposed to be distinguishable from the viewpoint of the agent? And only when you have settled that question, then it makes sense to ask what kind of beliefs does the agent have and so on. How can I satisfy the Humean thesis? And that's a bit unexpected, and that might be a drawback of the theory, because many people like the idea that belief is sort of not relative to context. Maybe pragmatic acceptance is relative to context, but belief is not. But if this theory is right, if the Humean thesis is right, then also rational belief is very sensitive to the context. Like here, to thresholds, spaces of thresholds, and partitions. Okay, final consequence of the theory. Of course, we also want to base action on belief. And like we have two kinds of belief, right? All or nothing belief and degrees of belief, there should be two kinds of decision theories. Qualitative decision theory and standard Bayesian decision theory. Okay? Now, what's qualitative decision theory? I don't develop that here, but it's very simple. At least I set it up in a super simple way. Okay? It's roughly this. Say you believe, given some goals that you have, an action is useful, right, to achieve that goal. And then you have an action that you do not believe to be useful in order to reach that goal, right? Then you should prefer the first action over the other, right? So this is basically it, okay? Super simple qualitative decision theory. Now the thing is, if the Humean thesis holds, then you can prove that very simple-minded decision theory to be more or less okay from the viewpoint of Bayesian quantitative decision theory. And that's how it goes. So I assume again the Humean thesis and probability theory. You have a set of outcomes, possible outcomes of actions that you have, right? You have utilities, which you assign to the outcomes. But I'm presupposing a very simple setting. There is only two utilities, a bigger one and a smaller one. It's like saying the bigger one is saying, that is useful to me, and the smaller one is saying, that is not useful to me. So although I'm not presupposing that, you might think to yourself for the moment, the one is 1 and the other one is 0. Okay, useful, not useful. Okay? And then I have actions, which are functions from the set of worlds to outcomes. So you have an action, you apply it in a certain world, and what you get out there is an outcome that the action has in that world. Okay? And in fact, it's a very liberal setting. All these functions are actions, in my sense. Okay? And then finally, if I pick an action A, okay, I can collect together all the worlds such that if I generate that action A in that world, and hence I produce an outcome, and I check for the utility of that outcome, the outcome of that action in that world will be the good outcome, the useful one, the bigger value. Okay? Collect together all the worlds in which the action A produces the good outcome. this set of worlds I'll call the set of worlds in which the action A is useful. Okay, it's the proposition expressed by A is useful, or A is desirable, or something like that. A is good. Okay? That's a proposition now, right? A set of worlds that the agent can believe or disbelieve or suspend judgment on. And now the following can be shown. First of all, take any two actions A and B. If the agent believes A to be useful, and the agent does not believe B to be useful, then the expected utility, in the standard Bayesian sense now, of A is indeed greater than the expected utility of B. So if qualitatively, in terms of all or nothing belief, you think that A is better than B, then this is also so in terms of standard Bayesian decision theory. Okay, that's good. Secondly, if Bayesian decision theory thinks that A is permissible, that is, the expected utility of A is maximal. That's one of the candidates that the agent might go for, right? Because it maximizes expected utility. Then such an A is also one that qualitatively the agent deems to be useful, believes to be useful. So the best normative option, the best decision from the Bayesian viewpoint is also among the best options from the all or nothing belief viewpoint. That's also good. And finally, if you fix such an A that is optimal from the Bayesian point of view, and you take any action B that the agent qualitatively regards as permissible, that is, where the agent believes that B is useful, right? Then this B, while it doesn't have to maximize expected utility, that would be too much to ask for, right? You lose some information when you move from P to Bell. But you don't lose too much information. That's what I'm saying here. If you compare the expected utility, that's the best choice in the Bayesian sense, with the expected utility of any B that's optimal from the all or nothing point of view, then their difference is not too big. It's less than the maximal utility minus the minimum utility. Remember, these were these two utilities that I have over 2. So sort of the expected utility of this other B that is permissible from the viewpoint of belief, it's closer to the maximum than to the minimum, right? So meaning, if I follow just my qualitative beliefs and my two utilities, that's like qualitative utilities, and I do my qualitative decision theory in the expected sense, then the Humean thesis entails that my decisions are sort of okay. I can't mess up too badly, even from the viewpoint of the normative theory of Bayesian decision theory. Okay? So basing action on qualitative beliefs is fine, given the Humean thesis. And that's good. So we're actually allowed, right, normatively permitted to base our actions on our qualitative beliefs as well. All right. Rational qualitative decisions are probabilistically reliable. Okay. Now I have 2 little examples just to illustrate what has been going on, and then we're done. The one is, this is my probability measure again. So that's the one that I used throughout the talk in my examples, right? And you might have wondered, where does this measure come from, right? Because it has these strange numbers, right? And I picked that measure from a paper by John Dorling, paper in Bayesian Philosophy of Science. And what he does there is he reconstructs in a typical Bayesian manner a little episode of 19th century physics. Okay. Now I give you a caricature story of that. The caricature story is, it's about the secular acceleration of the moon, right? So the moon is accelerating, right? Which, as I always say then at this point, I find sounds dangerous, right? Because just sort of, where is it, right? But then again, it's more about the Earth getting slower in terms of rotation, which is not that frightening. Okay? Anyway, that's the phenomenon. They wanted to explain the secular acceleration of the moon at the time in terms of the physics at the time, and Laplace thought he had it, but then he was proved wrong by John Couch Adams, a British physicist proving a Frenchman wrong. So they had a problem, right? That's why we have a 0 here. So that's the relevant part of Newtonian physics, Newtonian mechanics, that's T. That's auxiliary hypotheses that were used at the time, like the tides don't matter. Tidal friction is negligible, you can forget about them. That's H. And then you had the evidence, the observations that they had. But you can't have all of them together, okay? So something must go, something's wrong here. So this would sound like a typical Quine-Duhem problem, right? So either you drop Newtonian mechanics, the relevant part, or you drop the auxiliary hypothesis, right? And you could go either way. And then the Bayesian story that John Dorling presents here is, well, let's cook up the probability measure of the ideal astrophysicist at the time. Obviously, that's a thought experiment, as you can imagine, right? And he ends up with that measure. he does that in a clever way. So it doesn't sound, it's not like, and here it is, right? So he does that in a very principled way, okay? But anyway, that's what he ends up with. And then we do what every good Bayesian would do. We update that measure on the evidence. And then what we find is that the degree of belief that we then assign to Newtonian mechanics is still very high. But what we assign to the auxiliary hypothesis is really low. And that means we should give up the auxiliary hypothesis and not Newtonian mechanics. And of course, that's what people did, right? The tides do matter. They can't be neglected here. So as a Bayesian philosopher of science, you now say, yay, right? Well, there's no Bayesian philosopher of science here. Otherwise, you would have said, yay, right? Because that sounds really nice. So in a sense, using the probabilities, you get rid of the Quine-Duhem problem, okay? At least in this case. But then again, Dorling also says, while I will insert definite numbers so as to simplify the mathematical working, nothing in my final qualitative interpretation will depend on the precise numbers. And it better be so, right? It can't be that it's important that you have 3, 4, 2 here, right? That's a thought experiment after all, right? So it couldn't be about the numbers, right? But then again, it's funny for a Bayesian to speak of qualitative interpretations, right? What is that in the Bayesian theory, right? If it's not anything ad hoc, right? But then again, what we can do is, here, we take the probability measure, and we assume the Humean thesis like we did anyway, and then we see what the theory predicts. And the answer is, if I pick a reasonable threshold, like in the Humean thesis 3/4, that would be the corresponding Lockean threshold that you get, and you determine Bell so that the Humean thesis holds, then what you find is, well, he's right. So the rational agent at the time should believe in Newtonian mechanics given the evidence, but they should believe in the negation of the auxiliary hypothesis. And that is now qualitative, right? By definition, that's the qualitative or categorical scale of measurement here. So he's right, okay? And you can also show that if you have a bell and you fiddle around with the numbers a little bit, then that bell won't change. So he's also right that the exact numbers didn't matter. Basically, remember my little triangles before. Any probability measure in one of these little triangles will lead to the same beliefs qualitatively. That's why you throw away information when you move from P to Bell. So he's right. Dorling was exactly right. But now we have a theory that actually justifies his claim, right? Rather than something ad hoc. And that's where I think it will be useful to have this joint theory of belief and degrees of belief, okay? He also says, when scientists debate, right, over coffee, then what they use is finite qualitative subjective probability assignments to scientific hypotheses. They don't throw at each other degrees of belief, right? But they say things like that is plausible, but given that, that is not so plausible anymore, and so on, right? And we have now a theory that will actually tell you which kind of qualitative assertions you should make, right, over coffee. And here's my final example. So Stefan is now in Munich, so I need to do stuff with Bayes networks, so I've included them. That's a Bayes network, kind of a standard one. I have that from a book by David Barber on probabilistic reasoning and machine learning. But it's a version of a variant of an example by Judea Pearl. You can see 4 random variables, the usual directly acyclic graph. We have our tables that determine the corresponding probabilities, okay? And the idea is Tracy, right, is at home. Before she steps out of the door, she thinks it's unlikely that it rained. It's unlikely that the sprinkler was left on, okay? That's why you have small probabilities here for it raining, that's R equals 1, or sprinkler being on, that's S equals 1, right? But then she might, step outside of the house and see, well, my lawn, Tracy's lawn is wet, okay? And of course, that could have been caused by the rain or by the sprinkler, right? She might or might not also see that her neighbor's Jack's lawn is wet. That wouldn't have been caused by her sprinkler, right? It's Tracy's sprinkler, but it would have been caused by the rain with a small probability that there might be a different cause. Maybe he also has a sprinkler, right? And then you determine the probabilities sort of in a natural way, and you end up with a Bayesian network, which, of course, determines a probability measure, right? And now what we can do using the Humean thesis is we plug in that probability measure into our theory, and we determine what kind of qualitative beliefs Tracy would have about that situation, okay? And that should remind you a little bit of Hume again in the treatise saying, well, unless it's belief in relationships between ideas or belief that is triggered immediately by perception, all belief arises only from causation, as he says in the treatise. Okay? And that's what you get when you apply the Humean thesis. Remember, the Humean thesis actually determined a ranking of worlds, and that's what I do here. So I apply the Humean thesis for a threshold of 1/2. That's my Humean threshold. And then I get a ranking of worlds out. That's a world. A world is just an assignment of being true or not to our random variables, right? So that's a world where you can see it didn't rain, the sprinkler wasn't on, Tracy's lawn is not wet, and Jack's lawn is not wet. That's what she should believe initially. But then, given additional information, right, she should change her beliefs. And how? This is what you get according to the theory. And that's what you get when you do, as I said briefly in the course of my talk, you can do the whole thing in terms of conditional belief rather than absolute belief, right? And just to give you a flavor of that, that's what you would get. For example, the agent, according to the Humean thesis, should believe if it was raining, let's look here. If it did rain, then both of our lawns will be wet. Right? Given that the sprinkler is on, my lawn is wet. Okay. Given that both of our lawns are wet, it was the rain and not the sprinkler. Okay. Given that my lawn is wet and it wasn't raining, the sprinkler was on, and so on. So you can see how that works. So in a sense, you can do Bayesian sort of causal reasoning in qualitative terms if you plug in Bayesian networks and combine them with the Humean thesis. Okay. And that's the end of my talk. The idea was we have one bridge principle for degrees of belief versus qualitative beliefs. The theory has lots of attractive consequences. I've given you 3. You can derive doxastic logic, an instance of the Lockean thesis, and qualitative decision theory to be reliable from it. There is a price to pay for the theory, a strong context sensitivity. For example, it's important how you partition your set of worlds. That plays a big role. And there are lots of applications of the theory. I've just given you 2 at the end, but there is actually a lot more. Okay? That's why I'm going to end up writing a book on that, okay? Because it grew bigger and bigger. Okay? So after all, I think there might be hope for a joint formal epistemology for belief and degrees of belief at the same time. Thank you.
Thank you very much for this rich lecture and challenging lecture. We have some 20 minutes for discussion and comments. My belief is there will some questions and some comments following this lecture. And I was instructed that, and reminding me that there is a special procedure. Please take the microphone before raising questions, and also the speaker is invited to repeat the questions. So, first on the
So initially, I found myself very resistant to the idea that it's essential to beliefs that they be stable, and found myself thinking in terms of the following example. I believe that Peter's lecture is going to start at 9 o'clock. Now, mind you, this is a lecture which if I miss it, I don't care. Don't care that very little. I don't think, qualitatively, intuitively, that's a stable belief at all. I mean, if somebody comes along and says, well, there was a misprint in the program, or somebody comes along and says, Paul, you didn't put on your reading glasses before you read it, that says 8 not 7 or 8 not 9, whatever. I mean, the belief is going to go out the window like that. However, then I thought, oh, he's got this condition on conditionality there, and what does have to hold, again, qualitative before we get to your theory, is if I believe that the context, I got the time from the program, I do have to believe that there was no misprint in the program, and I do have to believe that I put my reading glasses on. So the upshot is that I don't like the description, the rhetoric of stability it's a kind of pragmatic internal coherence that's required. And thinking of it that way, I'm finding this all very interesting and attractive.
Well, I'm glad about the second part of your comment. Yeah. And thanks for answering your question. I mean, let me also add one thing. As you could see in my examples, right, the Humean thesis underdetermines what your system of beliefs is like, right? Even if P is fixed, right? And you can choose a bell that is very cautious, and you can choose a bell that is very brave, right? So, for example, that you don't care that much, right, about his lecture could show up in the way that you push your threshold downwards, right? Meaning, yeah, you know, if I miss it, if things go wrong, who cares? Let me believe it, okay? That's fine. So if you really care very much, right, then this would show up in a way that you push your threshold upwards. Then it becomes really important for you that you can rely on that, right? The other thing that is sort of, yeah.
So stability, what counts as stable is going to be very dependent on what's at stake.
Yes, that's perfectly fine.
Is that a
yes,
feature of the system?
Exactly. That's exactly how I think about it, right? When I say that belief is it's much more contextual than you would have thought, right? Then this means it's much more pragmatic than you would have thought. Yeah, exactly right.
Any other questions, please? Just a moment. Yeah, but it's the rule. Sorry.
I was wondering what exactly is packed into your perfectly rational agent.
Yeah.
And I'm naturalized in my approaches to things, and so I just don't always know what it means. I don't think I ever know what it means, but it got me thinking about the idea of properly basic belief. So Plantinga's idea of properly basic belief, and whether your rational agent could have a properly basic belief that was unrevisable in any context. Or is that in some way ruled out through the probabilistic approach? I was just curious.
It's not ruled out, but it's not entailed by it either, right? I mean, so this business about perfectly rational, what it means here really on the probabilistic side is that I always assume that the axioms of probability are satisfied. So we're not dealing with agents whose degrees of belief invalidate some of the axioms of probability. What it means ultimately, as you've seen on the all or nothing side, is I'm only dealing with agents whose beliefs are closed under logic. And then it means, finally, that her beliefs and her degrees of beliefs together satisfy the Humean thesis, right? Of course, that was the thing that I argued for, right? And what was in the background were the other two, really. But since we derived stochastic logic, basically, the basic thing is that I'm assuming my agents to have degrees of belief that satisfy the axioms of probability. And in that sense, they're ideal, right? Because we wouldn't think that of everyday agents, right? But then again, you know, it's not that this means that there is this super huge gap, right, between sort of this purely normative story and the empirical story. Otherwise, Bayesianism would not be useful in empirical areas, but it is, right? For example, in cognitive psychology, you know, there's a big Bayesian research program going on. So it's not that this is sort of very far apart from the real world agents. There should be nice bridges that can be built. But I have to admit, in my theory, I presuppose the axioms of probability always to be satisfied. And if you have an agent that doesn't satisfy this axiom, then as the theory stands, I can't predict anything for it. That's what it means. That's why I'm saying inferentially perfectly rational, right? It's sort of, the degrees of belief are perfectly coherent in a sense. Yeah.
Okay, thank you.
Thank you very much. It's a very wonderful presentation.
Thank you.
One complaint I have on many of the theories about rational belief and probability is that usually they consider belief or probability as a kind of goal of epistemic activity, but this leaves unexplained in many cases what is the reason to pursue additional evidence beside the evidence we have. I mean, once we have the evidence we have, this determines a certain degrees of probability or beliefs, and well, why are not happy with that? And so
right.
In what theory? What?
Right. So basically, you're saying in theories like this, sort of the agent is too passive. There should be some incentive for her to sort of actively search for new evidence of a particular form. Is that right? I've just remembered that I'm supposed to repeat the question. So, there is something that I can offer from the viewpoint of that theory. And it's this. So remember, I had this threshold R in my Humean thesis, right? And I told you at the start, it's sort of contextually given, but I'm assuming it to be at least 1/2. And I think that makes perfect sense for belief. Okay, so for example, it means that if an agent believes X, then the probability of X for that agent must also be greater than the probability of not X. So I commit myself to that, and I'm fine with that. But part of the theory is also applicable if you push this threshold R below 1/2. Okay? And now the question is, what's the corresponding kind of mental state that we're describing here? So I would say it can't be belief anymore. It must be something else. But it could be something like, say it's 0.2 or so, right? Then it would be something like a person is in that state if and only if she regards X to be salient or interesting. It could be something like it's a plausible scientific conjecture that X, right? It's not that if it's a scientist, she believes X, right? But she finds it plausible. And that could be sort of an X that she then actively investigates in order maybe ultimately to bump up the degree of belief, right? Because she ends up believing in the conjecture, or maybe abandoning the conjecture, pushing down the degree of belief, disconfirming it by new evidence, right? And if you do that, if you push the threshold to a small number, below 1/2, then you can still apply the theory. And the theory is going to tell you, very roughly, what are the plausible, interesting conjectures that you can have if you want at least your system of conjectures to be closed under logic and to relate your degrees of belief as being given by the Humean thesis. So if you do that, what the theory will predict is that's an interesting conjecture to look at, that's an interesting conjecture to look at, and that's an interesting conjecture to look at. And then she might, go ahead and explore these options. So there could be some incentive for searching evidence that derives from the theory. But I have to admit, I haven't studied that very much. But it's certainly there is a possibility. It's a good point.
Next question.
Oh, yeah. Thanks very much for your talk. I wonder if you can go back to the slide where you defined the POS-Y.
Can you say again?
A POS-Y, the POSSY. It's toward the beginning.
Sorry, I just didn't understand.
When you define POS-Y,
Post-Y.
possibility, yeah.
Oh, POS.
Yeah, that's it.
Sorry, yes. Sure. You mean the beginning of the talk, right?
Yeah, I think it's right here. So just a small point. I was wondering, intuitively, POS-Y should have something to do with what the laws of nature are, right? I mean, what you believe is that completely, what you take to be possible shouldn't be independent of, what the laws of nature are. I mean, is that a further constraint?
I see what you mean, but as you know, there are different notions of possibility around, right?
Oh,
so what you have in mind is physical possibility, right? But what I mean here is doxastic possibility from the viewpoint of an agent, right? It's like the P here, right, is really an agent's degree of belief function, and not nothing like an objective probability measure. Like, it's not about objective chances, for example, or anything like that, right? So the POS here is not metaphysical possibility, nor physical possibility, but it's something that possibility as being given by the agent's beliefs, right? It's a serious possibility in the sense of Isaac Levi. Right? So it's a purely subjective thing.
all right.
So the preview is 3 minutes and 2 questions. Only short question, 2 short questions, please, and maybe summarizing. Regrettably, at the end of the audience, the last one, Sportivo.
Okay, thanks, Hannes. Is this on? Yeah. So I'm wondering if I can believe it possible. I'm going to try a philosopher's trick on this theory, right? So can I believe that it's possible that most of my beliefs will eventually be, in the long run, eventually overturned, say by scientific progress?
Right.
Because if that's, so in other words, I don't qualitatively believe that that's false. That's the sense of POS, right? Because if so, then of course that goes into the conditioning, the conditioning propositions, and then I can just run that on any proposition, and it ends up having as low of a probability as you like, right? If you tell the story in a certain way.
Yes. No, very, very good question. So what you're saying is basically what happens if we extend that to second order beliefs, right? Because that's effectively what you're doing, right? And what would be the effects, right? Now the theory as I've presented it here was not about second order beliefs, but in principle something like this is possible, right? And my guess is that if you end up setting your space of possibilities in that way, the way you suggested, you will basically become super duper cautious and only believe stuff maybe that has probability 1, right? But then again, at the end of the treatise, right, that's exactly what Hume would describe, right? That's why it's a skeptical book, right? So at the end he says, the everyday person, right, the landholder, that's one of his examples, right? They have, lots of interesting beliefs, and if he's in the right mood, he shares these beliefs, right? But then again, if he wears his philosophical hat, that's what he does at the end of the book, right? Basically, I'm questioning now the reliability of my judgment, right? And can I really believe in that causal stuff and all of that, right? Then what I end up with is I destroy all of my beliefs. That's what he says. And that's exactly what you said, right? So the answer is, if you're in a sort of everyday context where you wouldn't do that, you have lots of nice beliefs and they have the right logical structure. But if you go to a very philosophical context where you're sort of questioning yourself in each and every way, then probably the theory will predict that you end up believing just conceptual truths or something like that. Okay. But I'm fine with that.
Last question, Miklos.
Yes, thank you. The content of this Humean thesis depends very sensitively, as you argued very clearly, on what the Bell X is. And you specified it in a particular way and showed that it has nice consequences.
Yes.
Do you see any other way of specifying it in any other interesting way other than the one which you declared to be the winning way of specifying it?
Right, good question. So the question is, instead of plugging in that here, right, maybe we have a different interesting choice, right? I mean, I've played through some of these options that I found wanting. Initially I thought that might be an interesting option, but nothing much emerged from it. Here's something that one could look at. What about if we plug in all the y's that have at least some kind of minimal probability, right? Where the probability of that y is above a threshold, right? Little t, okay? That's an interesting option. Now, actually, the funny thing is if you accept that thesis here, right, my Humean thesis, then you can actually derive that from this thing, you can derive the same statement again where you replace pos by probability of y is greater than some little number. So what I've just suggested you can derive here. But maybe what I just suggested could be taken as the principle itself. And then I'm not quite sure what happens in general. That would be a very reasonable option to look at. But other than that, I'm sort of lost. I don't see any interesting option left. Maybe one of you has an idea. Yeah.
Thank you again for the lecture.
Thanks so much. Thank you.
Thank you.